Hello there. In 7.3, we were talking about the addition, subtraction, and we're also going to talk about least common denominators. But first, looking back to look forward, how do you add and subtract fractions? Right, we add or subtract the numerators, and we keep the denominators. So what I would like you to do is I want you to go ahead and add the first three problems right here, or subtract. So add, subtract, add. And then when you're finished, unpause the video and check yours with mine. Okay, so for the first one, you can see we get 3/4. For the second one, we get a -1/6. And lastly, we get a 1/2x squared. Now this one might look a little bit different than anything you've added before, but if you use the same process you did in the first and second one, then this one you shouldn't have any difficulty with either. So to just walk through them, first thing is you take the numerators and either add or subtract them. And then we simplify, meaning we take out any common factors. We notice in the first one they have a common factor of 2, so I factored them and then I factored that 2 out. And in the second one, again, I factored out the 2 and I simplified. When we add this third one, 2x plus 3x is 5x, I noticed that they have a common factor of 5 and an x. So I rewrote them and in factored form is 1 times 5 times x and then 2 times 5. And then I changed x cubed to x times x squared, cancel things, and we get our answer. We're going to be using the same process to work through these following problems at the bottom. I'll do one and then let you do the others on your own. So let's go ahead and let's see, which one should we do together? Oh, I think they're all pretty much the same idea. Let's go ahead and look at numbers. We'll look at number 3. So just like we did in the first part, you're going to add the numerators. So we have x minus 5 plus 2 and keep the denominator, x squared minus 4x plus 3. Then we need to simplify. So x minus 5 plus 2 would be x minus 3. And then we can change this denominator. We always want to factor things if possible in the last step because we want to see if it simplifies. So we could change this to x minus 1 and x minus 3 because you can double check x times x is x squared minus 3x minus 1x plus 3. These two give you a -4x. So that's what we want it to be. So now we can see that they have an x minus 3 and an x minus 3. Now to write our final answer, we have an x minus 1, but keep in mind that x minus 1 is in a denominator, so you need to leave it in a denominator, which means in the numerator we have a 1 because everything cancels out. Just like we saw up here, if everything cancels in the numerator, you're left with a 1. Okay, now what I'd like you to do is I want you to pause the video and work through numbers 1, 2, and 4. When you're finished with those, unpause the video and check your answers with mine. Okay, you can go ahead and check all your answers with mine. Keep in mind, in a problem like number 1, these n's do not cancel because the n in the numerator is a term. Same idea with the x's in number 2. You cannot cancel them or the 7's because they're terms, they're not factors. And also in number 4, you cannot cancel the 4x's because the one in the denominator is a term, so you can't cancel the terms. Another thing you can do to check your answers, and this is good practice, is check them just like we did in the previous section. For example, number 1, you type all of this into y1 on your calculator, then type your answer into y2, and all the y values should be the same, meaning the graph should be the same. Notice that these are all addition problems when you have a common denominator. 4.2 is going to be looking at adding and subtracting without that common denominator. Okay, the next thing we're looking at here is subtracting rational expressions. This is going to be the same process, but we have to be very careful with the subtraction sign. Again, notice that we have common denominators with all of these. So we do the same process, subtract the numerators, keep the same denominators, and then simplify. So let's go ahead and look at one of these together. Let's go ahead and start. We'll look at number 3 again. All right, so again, first thing we do is subtract the numerator. Well, I'm going to write the first one. I'm going to subtract. Now we have to subtract that whole second numerator. So if you want, put parentheses around it so you don't forget to do that, because we have to distribute that negative to all the terms in that second numerator. And then we're dividing by the x minus 1. So now we actually do the distribution. Minus 11x plus 4. over the x minus 1. Now we can combine like terms. So 3x squared, this would be minus 7x, and then plus 13. And then divided by x minus 1. And then we have to see if that numerator will factor. So just to do some scratch work here, if we have 3x and an x, well, with a 13, it's going to be a 13 and a 1. So if we put a 13 and a 1, that gives us 13x, but that gives us 3x, which isn't going to give us a 7. And just to verify the other way, if we had, let's see here, if we switch those numbers around and we had 13 and 1, well, that's going to give us a 39 and a 1x. That's not going to work either. So therefore, we know that this is the answer, and it does not factor at all. Okay, so now you're going to use that same process to subtract numbers 1, 2, and 4. When you're finished, what I'd like you to do before you unpause is check your answers using your calculator. Type in this into Y1 and then your answer into Y2. Do that for all of those and then unpause the video and check yours with mine. Okay, so for the first one, you should get 3x plus 4 over x plus 3. And then for numbers 2 and 4, I just wrote the answers here. And I want to see if you did not get those correct. I want to see if you can find your mistakes yourself. One thing to double check with first, if you did not get these answers, is did you distribute this negative to the x and the 30? Same thing here. Did you distribute the negative to all three of those terms in the second numerator? So go back if you didn't get these answers, see if you can find your mistakes. If you're having difficulties with 2 or 4 or anything here, make sure you reach out to me either via email or you ask me in class, and I can take a look at your work to see where you went wrong. Okay, let's move on to the next page. Now what we're going to be talking about is least common denominators. This is going to be what we have to use when we are adding fractions that do not have the same denominators or subtracting fractions. Before we get to that, we need to figure out how to find a least common multiple, especially when we have multiple factors with a binomial, perhaps. Okay, so for the first one, we want to find the LCM of 6x squared and 4x cubed. Well, the first thing we want to do is factor a 6 and a 4. You can ask yourself to make it easier, what number goes into both of those evenly? The biggest one, you might say, oh, a 2 does. So we want to factor a 2 out of each of these. So a 6 would be 2 times 3, and we can write an x squared here. Now 4x cubed, we can say, all right, 2 times 2 and x cubed. Now what we want to do is find a factor that has all of those components in it. So meaning I always start by rewriting the whole thing of one of them. So I'm going to rewrite the first one here. So I have a 2 times 3 times x squared. Now I go up to the second one and I say, okay, what is it missing? Well, this one has 2 2's. I only have 1 2 here. So I need to add a 2. And then I say, okay, this has 3 x's. I only have 2. So I need to add another x. And then I multiply all these things together. 2 times 3 is 6. 6 times 2 is going to be 12. X squared times x is x cubed. So the least common multiple is 12x cubed. Okay, I'll let you try 2 and 3, but let's go ahead and look at number 5. So number 5, we have something completely different because now we have binomial and a trinomial here. We want to use the same process. So first thing you want to do is factor both of them, just like we factored number 1. X squared minus 4, this factors to x plus 2, x minus 2. Whereas x squared minus 2x minus 8, that would factor to x minus 4, right, and x plus 2. So now to find our least common multiple, again, start by rewriting the factored form of one of these. So x plus 2, x minus 2. Now go to your other factorization and ask, what is it missing? Well, it does not have an x minus 4, so we need to add an x minus 4. And you can see it also has an x plus 2, which we have an x plus 2, so we do not need another one. And that would be our least common multiple. Go ahead and do 2, 3, and 4, then unpause the video and check your answers. Okay, looking at number 2, we notice that they have a common factor of 8, so I rewrote each one I factored in 8 out, so we have 8 times 2a, 8 times 3b. So then I take the first factors and I rewrite them, and I ask what's missing. Well, we already have an 8, but I need a 3 and I need a b. Multiply together, 48ab. Number 3, I notice that they both have a factor of 6, so I have 6 times 4, x to the 4th, y to the 4th, and 6 times 1, x to the 6th, y squared. Again, I rewrite the first one, which is what we see here, and then I go through. We have a 6. 1, okay, doesn't really matter because 1 times 1 is 1. X to the 6, well, I only have 4 x's, so I need to add 2 more, so altogether I'd have 6. Y squared, well, I have 4, so I'm good there. Multiply, we get that. Number 4 is pretty easy because x plus 1 and x minus 1 are already factored, so you just write those two factors next to each other. Okay, now what we're doing in this last part here is we are going to be writing equivalent expressions. So now the least common multiples that we're working at here are now in the denominator, so now they become least common denominators. So what we're going to do here is let's start with, we'll do number 3 together. And then I'll let you do 1, 2, and 4 again. So what we're going to do first is we need to factor the denominators. So we start with y plus 2 over, and then we factor this. This would be 4 times y plus 4. And we have this comma, and we have 2 over y and y plus 4. So now we want to find the least common denominator again. So just like we did in the previous part, we're going to take each denominator and put them together, if you will. So, okay, we have a 4 and a y plus 4 from this one. Now we have to look at this one. There isn't a y, so we need to add a y. There already is a y plus 4, so we don't need to do that again. There, we can say the least common denominator would be 4y times y plus 4. Now we need to rewrite each of these fractions to have the least common denominator. But we can't just put this in place of it because we can't change the value of the fraction. So we're going to start by writing the original. So y plus 2 over 4 times y plus 4. And then we ask ourselves, what can we multiply this whole fraction by that'll get this denominator to be the least common denominator? What factor is it missing? Right, it's missing a y. So we need to multiply that denominator by y. But if you multiply the denominator by y, you have to multiply the numerator, or else you'll change the fraction itself. And then we do the same thing, 2 over y times y plus 4, and you say, okay, again, what can we multiply this denominator by to give us the least common denominator? Meaning, what factor is it missing? And it's missing the 4. So if we have to multiply the denominator by 4, we have to multiply the numerator by 4 as well. Now we just need to simplify. You have to be careful. So we have y plus 2 times y. So we're just going to, for now, we're just going to write it like this. Over, and then 4y times y plus 4. And I'm running out of space here. And then we do our next fraction. 2 times 4 would be 8 over, and then again, 4y times y plus 4. And that would be our equivalent expressions. Typically, if you have monomials, you multiply them together and stick them in front of the binomial. Okay, what I'd like you to do now, just like we've done the previous pages, is pause the video, work through numbers 1, 2, and 4. When you're finished, unpause your video, check with me. Okay, and then what you can do is check your answers with 1, 2, and 4 with mine. And if you have any questions on anything or the process or why I use certain least common denominators, make sure you reach out and ask. That's all we have for 7.3, and 7.4 we'll be then taking problems just like these, but instead of putting commas between all these fractions, we'll be putting addition or subtraction signs. Good luck with the homework, and we'll see you in class.